Most electronic devices include ESD protection circuitry to guard against ESD events the device can be expected to encounter. Typically, the design engineer selects these ESD protection devices based on the rated protection voltage listed on the datasheet, includes the part in the design, and everything is fine. But sometimes, a device will fail ESD testing at a voltage much lower than it is rated for, or maybe a customer experiences an ESD failure. This often leads to frustration and confusion with little or no answers to the question, why did the ESD protection fail? The answer is not always simple. Protection devices can only be characterized in the one way they'll never be used, alone. Due to the current sharing between the protection device and system, as well as protection rating of the ICs, the effective system protection level can vary from the rated level of the protection device by itself. Because of this, designers are often left guessing or attempting to divine a solution from the apparent black magic that is ESD protection. System-efficient ESD design, or SEED, is a simulation methodology that first defines the protection goal and information about the device under protection, or DUP, and runs simulations against this information to determine the appropriate ESD protection devices, effectively reversing the current approach to selecting protection devices. The DUP information includes the maximum DC operating voltage, the HBM ESD rating, the supply or I/O to ground resistance, and the series resistance between the protection device and the DUP. By adding this information to the required system ESD rating, it is possible to simulate the current sharing between the protection device and the DUP. This makes it possible to accurately determine which protection devices will work as intended, removing the guesswork and rules of thumb that are so commonly used in ESD protection today, and enabling designers to select the right device the first time and avoid the cost and delay of ESD failures. Littelfuse has incorporated this methodology and simulation capability into their iDesign ESD selection tool. The data presented is not based simply on datasheet specifications. Rather, it is based on the selected protection device paired with the user-supplied system and device information to provide a true protection rating, in essence, creating a dynamic datasheet for each part in any given situation. By partnering with Pragma Design to ensure the quality and accuracy of its ESD device models, Littelfuse provides designers with a platform to quickly determine, compare, and select the appropriate ESD protection device for their design. For more information on these and other circuit protection resources, visit littelfuse.com.